So suppose you have two vectors. I'm not going to put that arrow anymore unless otherwise specified. Vector notation, when I say A, referred to as a vector, it's a vector. Too much clutter for this. Suppose you have two vectors, A1, A2, using the book's notation, and B1, B2. Then the dot product is A dot B. A1, A2. Sorry, not bad. A1, B1 plus A2, B2. Good. An easier way to remember, you are doing A times B, so you do that to every single component and add them all together. So A1 times B1 plus A2 times B2, etc. Good. Here is a question. Dot product of two vectors is a scalar. True or false? Jake.
True.
Why?
Because I had this one.
Times it's 1. So if I have two vectors, I'm simply multiplying the values of the components. So if A is 1, 2, and B is 2, 2, what is the dot product of A dot of A and B? A dot B is simply 1 times 2, A1 multiplied by B1 plus 2 times 2. You have 2 plus 4, end up getting 6, which is simply a number. It's not a vector because in terms of vector notation, how would you write this?
Just 1, 2.
Like
I
using
had.
the basis vectors, mark that.
Just I had plus 2j had.
Do we
Not
agree,
yet.
Chris? Yes, and over here,
2i vector plus 2j vector.
agree. Now, if you use this expression, A dot B would simply be I vector plus 2j vector times 2i vector plus 2j vector. Things to note, I'll explain as to why. I'm going to write side notes here. I vector times I vector, a vector times itself in the basis case. Here, it should be 1. Yes. I vector times j vector will be 0. So same applies for j. j vector times j vector is 1. The order here doesn't matter. At the end of the day, you're going to get a number. That's it. Same usual math. If you rewrite that, you're distributing. I mentioned at the beginning of class, whatever that you can do with numbers, you can do with vectors. So 2 times I vector times I vector, 2 times I vector times j vector, 4 times j vector times I vector, 4 times j vector times j vector. Good. 0, 0, you go away. Put a note or star. We'll get back to this thing. I vector times I vector is 1, 2 times 1, plus 4 times 1. 6. But it doesn't matter which way you do it. I personally think this is easier. Yes. Okay, great. Oh, what is the point of this? Why bother about dot product? Good question to ask. Yes, no, maybe. Why should one care about a dot product?
Could it be when you're looking for the scalar resultant of two vector products?
Okay, scalar resultant of, excuse me, of the vector, yes, that's one. How about distance? If A and B are the same, what are you finding? If A vector, B vector are the same, so you have A dot A. What do you get?
A1 squared plus A2 squared.
You will get A1 squared plus A2 squared. Agreed. Jake, what did you have in mind?
The magnitude square.
Magnitude squared. So, dot product. Are we clear so far? Property number 2. If you have A1, A2. I'm doing only 2 dimensions because if you understand it here, you can extend it to higher dimensions. So magnitude of vector A, we know the square root of A1 squared plus A2 squared. Agreed? From last time. If you square on both sides, magnitude squared equals A1 squared plus A2 squared. Correct? I can write that as A dot A. Agreed. A dot A would simply mean A1, A2 dot A1, A2. Yes. Now, by my definition, simply means A1 times A1, A1 squared, plus A2 times A2, A2 squared. Good. Now, from last time, you could, the simplest case is we look at the vectors here, but in reality, you can turn it, and whatever applies here will also apply to any transformation. suppose I have two vectors. I'm going to start with a simple case. Whatever we do here applies in higher dimensions. I just don't want to illustrate using higher dimensions because it could get confusing easily. So here is another property explained via example. Vector. I'll put 4 there. Two vectors. Is there an angle between the two vectors? Yes. Sort of triangle, well, a triangle. Now there is an angle that we form between the two vectors, which is right here. There is a proof in your textbook as to why the following statement would hold true. It comes from law of cosines. We only stop at this class in terms of derivation. So I have two vectors. We know that there is an angle between them. So the dot product A dot B is simply the magnitude of A multiplied by the magnitude of B times cosine of the angle between them. Good. If you're interested in the proof, you can refer to text. It's not required for this class. Oh, I did put C there. So the dot product between two vectors is simply the magnitude of A multiplied by the magnitude of B times cosine theta. If you rearrange this, we can get the value of theta, the angle between the two vectors. Good. Simple case. And then you can try that one. Good. Two vectors. There is an angle between them. The angle is a right angle. Agreed. Well, if someone asked you, well, what is the angle between the two vectors? Just by or from the picture, you know that the angle is a right angle, so theta has to be pi over 2. I over two is in radians. What would that be in degrees?
90 degrees.
90 degrees. Good. Well, let's see if I can use that formula. A dot B, A in this case is 4,0, B 0,2. A dot B 4 times 0 plus 2 times 0. Yes, which is 0. I don't care as to what the denominator is. Sure, doesn't matter. To solve for theta. Why not, hey?
Because, well, we already identified that it's a right angle, so it's 90 degrees.
No, without using the picture. My question is, I found A dot B.
Mhm.
The formula to solve is right here. I'm saying I don't even want to bother finding these two. Why?
Because it will result in 0.
It's going to be 0, right? So I know the formula for cosine theta based on my definition, A dot B, dot product of AB divided by length of A times length of B, or magnitude of A multiplied by the magnitude of B. In this case, numerator is 0, so 0 goes to cannot be 0 because they are lengths. What is theta? You can't use the inverse function in your calculator. Theta is simply cosine inverse of 0, which is pi root. Well, this is something that I wrote already. I vector dot I vector is 1. I vector dot j vector is 0. Yes. That is simply a scalar multiple of the basis vector for x. Agreed. For I vector to j vector. Multiply those two, we're getting a dot product of 0. So I vector, j vector, are they dependent? Yes, we have a fancy name. The name, this is in property C, found the angle, so property C. If two vectors are orthogonal, in other words, they are at right angles, then their dot product is 0. Easy to visualize in 2 dimensions. Not so much in higher dimensions, 3, you can try, but it gets harder if you go to higher dimensions. So clearly, the standard basis vectors are at right angles. Now, I want you to compute the angle between 4, 0 and 2, 4. And tell me if, obviously, they're not orthogonal to each other. Agreed. So let's go ahead and find the angle between the two. So you need to compute the dot product and the length of A, length of B. To find theta, you will need your calculator. So we want to find the angle between this vector, 2, 4, and 4, 0. need to find the dot product, so A dot B. Component 2, first component, so 2 times 4. Second component, 4 times 0. Just multiply, then add. 2 times 4, 8. Plus 0, I get 8. Good. Dot product of A, B. Now, the next step is to find the length. Length of A. What is the length of A? Magnitude of A. How did we find it last time?
Just distance formula.
Okay, which is the square root of
2 squared plus 4 squared.
component 1 squared, 2 squared, 4 squared, which is square root of 20. Two root 5. For B, same. It's just 4, right? But I'll write it so you know. So 4 squared plus 0 squared. It's just 4 square root of 16. Good. We have all the necessary items to plug it in that formula. So A dot B is A. Magnitude, well, don't use that. Easy. So A dot B dot product of the two vectors, A, divided by the magnitude of A, 2 root 5, magnitude of B, 4, 1 over square root of 5. Yes. How do we solve for theta?
Inverse cosine.
Simply do inverse cosine in your calculator. So, depending on the mode of your calculator, you either get the answer in radians or degrees. I would say, unless you're doing problems in polar coordinates, set your calculator in radians at all times, because if you want to convert it to degrees, all you have to do is multiply by 180 and divide by pi. It's easy to do. So theta is cosine inverse of 1 over square root of 5, which is what?
63.4 degrees.
Yes. And in terms of radians,
1.1%.
you say 1.17.
It was 07. 107. I don't know if you want to round that to 1.
No, we just have 2 decimals. Accurate.
Well, no, I'm adding, it was 3, it was 1.107.
1.107.
Yes.
Okay.
So,
Are you sure?
yes.
Okay. You can write it in terms of pi if you want. This is the same as 63.4 times pi over 180. You can retain the pi and simplify that part. So that's approximately slightly over a third, 0.34. $63.4 for 180.
It's 1.1065.
No, I don't want the pi, I just need this part. 63.4 divided by 180,
0.35 to repeat,
3523.
to repeating.
Okay. So oftentimes, people would present it in terms of pi. WebAssign might want it in terms of pi. In which case, all you're doing is leaving pi as is, simplifying that. You will need that, especially when you deal with sines and cosines. Are we clear? Yes,
For this one, we could just ignore the found the angle of that triangle.
we could have, but, just wanted to show how the formula works. Some are just learning, right? So I can't go too fast. Let's see. Wanting to write a property, that's why I put it under D, but the would be an example. So consider the vector A. And vector B. I want you to find theta. Where theta is the angle between the two vectors. It's something else.
I was so confident, you feel so insecure.
Well, we can build it back. It's okay. I was wrong. I'm humble enough to agree. So we want to find the dot product here. So 4, 2, 4, 4. Dot product is simply 4 times 4 plus 2 times 4, which is 24. Yes? We want to find the magnitude of a square root of 4 squared plus 2 squared. Square root of 20. 2 root 5. Magnitude of the 4 squared plus 4 squared. What?
Four root two, I meant. Nice.
The square root of 32. 4 root 2. Yes. And cosine of theta. A dot B divided by the product of these two. So 24 divided by 2 root 5 times 4 root 2. So if you invert cosine, what do you get in terms of degrees? How much?
18.4 degrees.
Terms of radian,
0.32 radians. 32 radians.
0.32 pi, which is 0.3.
0.32. 0.322 if you round it, but
Approximate. If you graph this relative to the origin, 4, 2 is over here, 4, 4 over there. Yes. We're finding that angle. If I slowly move this vector and put it on top of the other one, let's say, give a new vector, moves, falls on top of it, would that angle decrease or increase? It's going to decrease, it's going to become 0. So let's just say you end up having. Should I do it this way? Multiple of that. That's two. Good. So new vector, call this C. Four is B, and that's A. What is the dot product of B and C? How much?
32,
32.
about 16.
2 times 4 plus 2 times 4. 16. What is the magnitude of B?
4 root 2.
B, 4 root 2. What is the magnitude of C? Square root of 2 squared plus square root of 2 squared, 2 root 2.
Right.
This is why I write it out. So 4 squared plus 4 squared, square root of 32, which is 4 root 2. 2 squared plus 2 squared, 2 root 2. Yes? So I can find the angle between B and C. What is the angle between B and C? You should know by now.
Oh, is there
0. Why?
a same picture? They're on the same picture?
So 16 divided by 4 root 2 times 2 root 2. Cosine theta, that's 1. This would mean theta is 0 degrees. We are looking between 0 and pi. Sure, trigonometric functions go round and round and round, but we are only looking for theta between 0 and pi. So 0 degrees, can I say that the vectors are parallel? Yes, so in general, if two vectors are parallel to each other, the angle between them is 0 degrees. Now, this could, to get 0 degrees, we would want B dot C to be equal to the denominator. If the dot product is 0, then they are perpendicular to each other. If the dot product is negative, well, we did a positive case. Positive number, yes. Another example from earlier, did we erase it? Here, positive number. Both angles are acute. Do we know what an acute angle is? 0 exponential. So this is the property E. If A dot B is greater than 0, in other words, positive, this would mean theta is acute. If A dot B is less than 0, take a guess.
Theta would be a
Sorry,
two.
just gonna read it.
Oh, geez. If it is equal to 0,
It's 9 degrees.
so that should be a special case where we conclude that they are orthogonal to each other. Good. So whatever conclusions we reach here will also apply to higher dimensions, 3-dimensional vector, 4-dimensional vector, and so on. Good. Okay.